Hello folks, we are once again back with as I always tell, the voluminous exercise 6.5, and we are now into the 25th question. Last time in the last video we completed the 25th question. So once again, yeah, it's a 25th question that we need to do. Now one common feature of this question number 25 and 26 is we are going to deal with the semi-vertical angle. It's not that we are going to that is given or something, but there is always some part of the question which is associated with the semi-vertical angle. You need to show something about the semi-vertical angle in both the questions. So let's just go through it, and we find that I kind of looked at this exercise more amount of questions are from cone, but that doesn't happen in the miscellaneous. We'll have all kinds of shapes, and here it's more of cone that has come in this exercise. So the following two problems also are from cone. Show that the semi-vertical angle of the cone of maximum volume. So that means you have to show that volume is maximum. And given slant height is given, is tan inverse of root 2. So they give you the slant height, they ask you to tell something about the volume, and yes, so and then they tell us, and then they also tell one extra bit. Always some questions have that extra bit, some don't have it. So that way, so let's directly get across. It's a cone of yours. Yeah, that's your cone. As usual, this is your cone which has got the height h and the radius is r, and it's got the slant height, and the slant height is a given quantity here for us, so that calls for work. Whenever slant height is given, it calls for work. So let's first introduce this and let's get going, because it is a bit of work. Let r comma h comma l be the radius, height and slant height of the given cone. Yeah. Okay, now right away we know that, because we have to reach to the slant height, and as we know, the volume is pi r squared h, where you have the variable r at h. We have to get them converted into known quantities, so that's going to be our task. So right away we'll start working. We know that L squared is h squared plus r squared. In a cone we always know that this happens because of the right angle that is there over there, and yeah, in our mind we do this. Volume is pi over 3 r squared h, two variables. We want to reduce it to one variable. Any one has to get substituted. Let's substitute r squared. Let's see how it goes. L squared minus h squared, 1. We keep a provision. Maybe if required, we can also switch h. Also, yeah, what do we know about the volume? We know that the volume V is pi over 3 r squared h. We are encountering this problem of two variables. So r squared from 1, we are substituting as L squared minus h squared. Let's check. So pi over 3 L squared h minus h cube. Alright, so that's our volume. Now in the next step, we're going to get the, as we know, we've got the volume. Obviously our next step is to get the dv by dh and the second derivative, and then the critical points and so on. So let's proceed on that lines. First derivative, dv over dh. It's pi over 3 L squared and 3h squared. And the second derivative, it is going to be pi over 3 L squared is a given quantity, doesn't have a derivative, minus 6h. From here itself it's very clear it's a negative quantity, so that is why it is going to be a maxima point. Yeah, so and now let's go for the critical point, where we'll consider dv by dh equal to 0, so that you have pi over 3 times L squared minus 3h squared equal to 0. Dividing both sides by pi over 3, you're left with L squared minus 3h squared equal to 0, which makes L squared equal to 3h squared. Now treat this as your critical point. Okay, h equal to L over root 3 is actually your critical point, but let's stop here and let's treat this as a critical point and check for the second derivative. Therefore, d squared v over dh squared is going to be minus 2 pi h. So it's at h equal to L over root 3 is minus 2 pi times L over root 3, which is negative, and hence maxima occurs. Okay, once we are done with that, we can move for our next step, which means they have asked us to show, a certain thing. All right, so we'll just get back to what they have asked us to show. They have asked us to show that the semi-vertical angle is tan inverse root 2. That means h over r. So you require h over r, where h you have in terms of L. Now let's see how can we get r. Let's quickly catch hold of this equation 1. Okay, let's catch hold of this equation 1. From 1, you have r squared as L squared minus h squared, but L squared is already 3h squared. So therefore, it will be 2h squared, which makes r root 2h when you take the square root. Now, if this were to be your semi-vertical angle alpha, let's add that also. Alpha, slant height, and semi-vertical angle. Yeah. So therefore tan alpha we know is going to be r over h. Now r we have got, h we'll write here. Okay, h is L over root 3 when you take the 3 on the other side. So therefore you get r over h. R is root 2h. And yeah, h let it be as it is. We not meddle with the h. So they will get cancelled. You get tan alpha equal to root 2, which makes alpha tan inverse of root 2. Hence proved. That's it. Quite simple actually. We have to be very focused with our work. Then things are quite simple. So that's how we show that alpha is tan inverse of root 2 for this particular cone, where they had given us a slant height and they have asked us to show maximum volume. Yeah. So all that is done. Obviously, with the next problem, we'll meet in the next video. Thank you.